right, very good VC panel that we just had. Next up, we're gonna have a keynote number 3. It's gonna be Ola VM.
I think we have some technical difficulties here, but we'll get started as soon as that is fixed. Yeah, perfect. So, hi everybody. My name is Philip. I am based out of Stockholm, Sweden, and I am the COO of Ola. My previous background is within computer science and finance. Been working with CBDCs as a solution architect and many different crypto tech stacks as well. And I am here today to give you a brief intro to Ola, which is a ZKZKVM. And we actually have a more thoroughly in-depth tech talk in the other room later today. We're going to be deep diving more into the cryptographic primitives and data structures and so on of the actual solution. And this will be more of a high-level introduction to Ola and what we're doing. And we are a team of about, I think, 17 people as of a few weeks ago. And we are mainly computer scientists and engineers, all of us. So, from a high-level perspective, what we're looking to do and solve are some of the fundamental issues that we have with centralized systems. Now, I think all computation does not have to be decentralized, but in a future world, it would be good to have options and have most of our valuable transactions to be interacting on a decentralized tech stack. And some of the existing tech stacks out there today, they're good in their own way, but they aren't decentralized. And that's the goal, right? So achieving a well-functioning web environment, we need to have higher scaling and throughput. We started off with Ethereum and Bitcoin and these decentralized chains, and we got that working. But the transactional throughput wasn't all that great. And then we got Ethereum. We started getting some programmability and the use of smart contracts, but we still didn't have that fast of a chain. After that, we started seeing some iterations on scaling, and we had things like Plasma come along and different flavors of rollups with Optimistic and CK. And on the slide here, we're showcasing some ZKVM solutions, looking to do scaling. And at Ola, we're looking to do scaling, but we're also looking to do privacy. So we think that privacy is a fundamental need for us to have a future decentralized infrastructure where we can actually have mainstream adoption. So these are one of the two main things. Privacy and scaling is the mission we're on, and bringing that to the Web3 space. So some of the problems that we're looking to tackle can be seen on screen here. So one of the big things is bringing back data ownership to the end user. Today, data can be scavenged across the pseudonymous chains, and that can settle most needs, but we want to truly make transactions private. But we don't want to tamper with the compliancy perspective. So we're looking to build out this tech stack, which is private, but still very compliant. We don't want to end up in a situation where you have agencies like the OFAC come knocking on the door and say, hey, what are you guys doing? We're going to shut you down. So we're building this highly private, but also compliant tech stack. Now, the premise of the entire solution is to bring public dApps and private dApps together. So we want to have one ecosystem where they can all live together, and we want to be able to give the users and the developers a choice, whether or not to deploy and interact with private or public dApps, or both. So essentially what this is a hybrid roll-up solution that we're looking to build out. See if this thing works. Okay, it stopped working. Can you go back? There we go. No? Oh, no, it's jumping. I think it's some delay in this thing, so I clicked a bunch of times and now they all came at once. Right. So essentially, this is the bread and butter of our solution. This is the core of Ola. And we are looking to build a highly efficient ZKVM. So the spectrum of ZK in terms of the Web3 ecosystem, it's really a spectrum of trade-offs. I'm sure you guys have seen different articles on different ZK EVMs, and how they are EVM equivalent on the scale of 1 to 10 or no, and vice versa, and Vitalik has opposed with type 1 to type 4, etc. We are not a ZK EVM. We are compatible with Ethereum through our compiler. So you can have your high-level language and you can deploy an OLA, and we connect with a smart contract to Ethereum layer 1. But it's highlighting that this could be any other chain. We could deploy on Celestia or Aptos or whatever that may be. We could even, if we wanted to, deploy on ZK Sync Era, which would make us an L3 then if we're using buzzwords here. But essentially what we're building is this encrypted execution environment. We're looking to bundle transactions and send them somewhere. And we want to do this as fast as possible and as succinct as possible. So this will inevitably be quite technical, but we have within our language then some features that we refer to as profit. And if we have any developers in here, this is very similar to what's known as hints in Starkware. It's essentially about taking computation, which is not very ZK friendly, and we take that out of the trace, out of the VM. It's still actually handled by the VM, but we can take that out of being proven. We can have it in some script, in some other high-level language, and we can just get the calculation back and prove the calculation was done correctly. And this helps with ZK efficiency. Also for developers, if you're familiar with built-ins, this is pre-compiled in Ethereum. So in the core of Ethereum, in the EVM, you have some functions you can call, or sometimes addresses as well, to these functions because it's more efficient. But we'll be touching more upon this in the technical workshop later today. We also have a RISC architecture, an ISA, instruction set architecture, and all of these are quite technical topics, so I won't touch upon that. But what I can mention is that our proving system is based on Starks. ZK Sync is an example given, recently also pivoted to using Starks. We have done a lot of research within our team on different ZK backends, and today we're using two algorithms known as Starkey and Plonky 2. And that's because they are Stark-based, they don't require a trusted setup. They both deploy the Goldilocks speed, which is good for us. And aside of that, we're also doing some things on the hardware side of things. We're improving what's known as NTT. I will not be touching upon this in this talk either. We can talk about that in the workshop later today. But all you can see here with the entire design is making as an efficient VM as possible. So if we go back to the article I mentioned before with Vitalik that a lot of people know about from type 1 to type 4, we're a hyper type 4. We're doing everything we can to increase the throughput in the system. Right, so let's talk about privacy. It's kind of become taboo to talk about this, and privacy is kind of frowned upon, but it really shouldn't be. I mean, privacy can and is compliance friendly. And this is actually a big differentiator between us and some other teams in the space in terms of the actual design and schemes here. So most of the teams that I know about in the space have many different trees, Merkle trees, where data is stored. And they have multiple trees so they can decouple the transactions with storage. So we don't want to be able to trace the transactions. So example given in maybe ACID or Aleo, you cannot trace transactions at all. Whereas we're going down a slightly different route. We want to keep the actual computation hidden to protect user privacy, but we enable the tracking, the backtracking of different users. So we're using UTXOs under the hood, and you're able to then per block backtrack to see where these funds came from. And why this may be important from the regulatory view is that what if North Korea comes onto your platform and uses OLA? Well, then we can see from the origin that some payment took place that went private, and we can follow those UTXOs to see what actually happened, which adds another layer of compliancy. And here we can see the two trees we have in our design. So we have one public root, and we have one private. And what we're seeing below here is just some composability with function types. So these are function types in OLA lang, which is our language. It's a Rust-like Solidity-like language, but I have another slide for OLN. This will also be more in-depth in the workshop we have later today. So touching upon compliance, and once again, if you think about your traditional chains, maybe Ethereum would be a good example. In Ethereum, we have what's known as EOAs, externally owned accounts, and basically you have a seed phrase which drives a private key and drives a public key. And in OLA, you have many more keys here. And this allows for greater functionality. So example given here, the viewing key. If everything is private in the system, nobody can see my data, but maybe I want to share my data with a third party. And I can do that by sharing the viewing key. So I can go to some regulator, or for tax purposes, I can showcase my entire history. Or maybe empowering the user. So you have teams like Shin Analysis out there, and their entire business model is around scavenging free on-chain data. But if they can't access that anymore, maybe I can approach them and say, hey, I'll share you my viewing key for $5 a month. So we're bringing data ownership back to the end users of the platform. And then we have OLN. So as I mentioned, OLA and OLN, it's a Rust-like, Solidity-like language. Our ZKVM is Turing complete. So you can deploy any arbitrary logic in OLN. And we have our constraints and gates on the actual virtual machine itself. And we take care of all the circuit writing. So that's the beauty. We want to abstract away all the complexities. It's like you're walking into a room and you want to turn the lights on, you just flip the switch. You don't need to think about how the copper wiring is wired behind the wall and how electricity is funneled down from the street. We take care of that. Developers just come in and build dApps, which is what they're good at, and we do all the CK stuff. And yeah, the roadmap. So we launched the POC this year in February. So you can actually already today, locally on your machine, go to our GitHub repositories, download the prerequisites, and you're good to go. You can generate your own proof locally. The next steps for us now is having an internal testnet where we whitelist people to onboard and try it out. And then end of year, Q4, we're looking to have a public testnet open to everybody. Also, in the top here, I'm not sure if you can scan from that far away, but it's a link to our Twitter, by the looks of it, and Discord, where you can follow the tech progress and see what we're doing. And I want to highlight once again, if this has been interesting so far, I will be later today diving into the cryptographic primitives and the data structures and more into the trees we were looking at to go through the design more in depth at a technical level. And I'll stop there. I think we're almost on time. Do we have time for questions or? Okay, so if we have one question, we can take that. Otherwise, we'll wrap it up. No, everybody understands OLA completely and fully. That's great. Yeah, that's it. Thank you. Yeah.
You said you could build in a compliant tech stack. What is it compliant to?
Can you speak louder, please?
What is it compliant to? You said you build in a compliant tech stack.
Right. So when I say compliant, so we had a scenario with Tornado Cash earlier, where you essentially have untraceable assets. And regulators across the globe, in the US, Europe, and APAC regions, they aren't really loving the concept that everything is private. So there's not one particular framework I'm referencing here, but I want to highlight that we are providing a very compliance-friendly infrastructure. We allow for the tracing of transactions through the system, and you also have extended functionality to share your data with third parties, meaning that we're not going to have a situation where assets are untraceable and you're trying to hide things. You know, compliance, privacy, it's kind of frowned upon, and it doesn't have to be that way. We just want to protect our data, and I think that's a fundamental need for mainstream adoption, but highlighting that we can do this in a very compliant way and work with regulators. All right, thanks so much.
Round of applause for All right. Next up, it's our third panel of the day. but I think Philip is still up. Let's give them a round of applause, please.
Yeah.
Hi guys, thanks for letting me moderate this panel. I'm Fede from Lambda Class. You can follow my craziness on Twitter, Fede_intern, until I get banned again, and I have to change my handle. I would like you guys to introduce you, to explain the core ideas of the blockchain you're building. On how do you see yourself in the space? Who wants to start?
Hey, I'm John, head of growth at Aztec. We are a privacy-first ZK rollup on Ethereum. We think of ourselves as a privacy-first ZK rollup, so privacy is at our core, but we also have a public execution plan.
Yeah, I was just on stage. Philip is my name, COO at Ola, and we're building, similar to Aztec, a privacy-centric scaling solution, an encrypted execution environment.
Hey guys, my name is Nico, and I'm one of the co-founders of Elusive. We're not building an own L1 or L2, but rather we provide privacy infrastructure for existing L1s, with which developers and end users can easily add privacy to apps they already use.
Hi everyone, I'm Kenny. I'm one of the co-founders of Manta Network, and we are specifically using zero-knowledge proofs for on-chain privacy. We have our L1, Manta Atlantic, which is focused on-chain identity and compliant private payments. And then also we have just launched testnet for our optimistic L2 that uses Celestia for data availability to lower transaction costs, with a focus specifically on developing and deploying ZK applications.
Yeah, we should use both.
So the next question I have is like, do you have any particular use case where using privacy is very important? Like obviously transfers is like the obvious answer, but is there any other type of application that you feel that your product will enable that cannot be done without ZK?
Sure, I'll go first on this one. So yeah, the question about anything else besides sort of on-chain payments. I think one other thing that is kind of, or not kind of, but very popular right now is on-chain identity. Thinking about every single data point, every single piece of information that you put on chain, mostly in the form of transactions, interactions with smart contracts. This is all fully public for the most part, right? There are certain chains in existence or being built, such as the ones that we're building up here, that enable these sort of private forms of identity. And I think that that's definitely a huge use case moving forward, especially if we actually want to scale out to use cases that actually have real world functionality.
Yeah, definitely agree with that one. But another one I think is huge as well is DeFi. Like for me personally, whenever I talk to someone who's not in crypto or not in tech, and I tell them what I'm working on, most people just assume that anything related to finance is already private by default, which isn't the case in blockchain technology. And of course, if you consider wanting to port over traditional finance, big investment firms or banking or anything like that over to the blockchain, you can't have it in a situation where everything is fully public, just because some trading algorithms, you don't want your competitor to be able to trace it at every step, or knowing what your current financial status is also not information that many people will even share with their closest family, let alone with everyone on chain.
Yeah, I think we touched upon the biggest two, which would be DeFi and identities. However, I spoke with a very interesting project, which I forgot the name of yesterday, where they wanted privacy on chain because they had a function where they're looking to have an AI bot where it can predict the price outcome for ETH, the asset, or any other asset for that matter, for the next 5 or 15 or 24 hours or minutes. And how that worked is that they had people do analytics, and they can predict their outcome, and they stake some kind of token by doing that. And then this algorithm will take their stake, depending on how big it is, and evaluate that with people who are against and for ETH moving up in price over that time point. And this is an example where the algorithm over time, hopefully, together with these analysts, would predict a good outcome. And then the problem is, if that is fully public on chain, meaning the analyst predictions, then you can just check the mempool and see what they think, and not purchase that data. So the key premise of this app is to sell a token containing the prediction and how likely it thinks it is from a scale of 1 to 10. And this is a perfect scenario where if that's already public, the predictions of these analysts, then why even purchase the data from the beginning if you have scalp the mempool for the predictions instead? So I think this is an actual example of where privacy could be useful, but if it's not there from the get-go, then these kind of applications couldn't be built.
I'll go in a different direction and say we've been working the last couple of months with Aragon on private voting architecture for Nouns DAO. And I actually think privacy is like an attack on socially centralizing forces. So we know that public voting is one of those things where, we know governance is functionally run in Telegram groups where people, DM each other and they're like, I can see the way you're voting. You better vote this way. Please do it on chain so that we can all see. Private voting allows you to credibly vote your heart's will, rather than the social will that's kind of communicated through Telegram. And we've enabled that through Ethereum storage proofs. And there's a bunch of governance problems that we think can be resolved through private voting, including 11th hour voting issues, where if you can see all the votes being tallied on chain, it behooves you to wait until the last minute, kind of whip up your votes through Telegram, and then publish them all on chain at the last minute and win. And so it really changes the game theory of DAOs, and we think makes them significantly more credible when it comes to decentralization.
Cool. Next question is, well, I will say something before the question. I wrote a paper related to Tornado Cash to de-anonymize transactions with some people from Stanford 1.5 years ago. And because of that paper, I got a difficult call at some moment, only for writing an analysis of machine learning on the transactions to correlate the transactions. It's called Tutela. After that, my lawyer recommended me not to work on privacy-related blockchains. I'm a big fan of privacy. I think it's very important. But to be fair, I got a little bit scared. How do you see the regulation coming? Do you think it will improve? How do you see the landscape?
I have a hard time speaking to the regulatory landscape, and I like to remind people that OFAC was not really a regulatory action, right? It was a national security action. And so
that's even worse.
Right, could be worse depending on how you look at it, right? Because it's totally unimpeachable. It's not an elected body that's making that decision. My belief has always been like they could have censored Ethereum, but they didn't. Ethereum by definition captures all of that activity that happened on Tornado Cash. So why did they not do that? Well, there's like some balance of harms happening, right? They're kind of weighing, okay, what's the benefit of Ethereum versus the harm of Ethereum? And they're like, okay, I got to just hyper target this one thing and like cut it out of the system. That's why we think privacy by default is so important. If accounts were, by default anonymized and everyone was just doing their thing, I don't think we would see privacy as a problem. It's a problem when a very, very small number of people elect into privacy and they happen to be users who want to do a very specific thing. And so I think when we normalize privacy through some of these use cases that we talked about and make them everyday and boring, I think regulators see that and they say, okay, well, that captures the entirety of blockchain. It's not like a specific group of people using this technology.
Yeah, so like encryption, like what happened with encryption, like it's massive.
Exactly.
Yeah, I think that those are very good points, and our teams are very similar values here. And I think encryption is really a good example. And this was almost before I was born, I think. The U.S. government tried to ban encryption, and they had this massive battle trying to ban it. And eventually, they realized they couldn't ban encryption. And I think it's kind of inevitably going to happen with decentralized tech stacks as well, that there will be privacy. And it's more of a matter of communicating and working with regulators. I think there needs to be a lot of guidance here and collaboration between the teams working on this and regulators. I also think, if I'm not mistaken, that you guys at Aztec even submitted your tech as a proposal to the Bank of England to their CBDC, which showcases that, well, you can actually utilize this tech for more centralized forms of blockchains. And I mentioned previously in my keynote here that I used to be a CBDC architect, and we did live implementations where our goal in this technical pilot was to mimic the properties of cash. And cash is not trackable. It's the most anonymized form of payment that we have out there today. You cannot track physical coins or dollar bills. And one of the things we did was looking at, well, can we mimic this entirely? And what we did then is that we looked at the option of having fully anonymous CBDC wallets, where it's kind of like a top-up card. So you're fully anonymous, but you can only top up to a certain limit. And that's just showcasing that governments also care about their citizens and how we can mimic those properties. So I think it's just a matter about talking with these regulators and guiding them as well of what we're doing at the commercial side of things and the decentralized side of things and how we can guide them.
Yeah, totally agree with both the points made so far. And yeah, I think the encryption comparison in the like 20, 30 years ago, something like that, it lines up pretty well with how ZK privacy is today. Because I think most governments aren't opposed to privacy in general, or they don't want anyone to have privacy and want to oversee everyone. Maybe I'm a bit optimistic, but that's my view of it. I think it's rather just that back in the day with encryption, they really had the view that, oh, this is only some arcane technology that's used by bad actors. And unfortunately, I think that's what many regulators, that's their view of ZK for privacy today, especially when they looked at the example of Trado Cash, which unfortunately had a couple of bad actors using it. So yeah, I do think it's a combination of, on one hand, communicating to regulators that privacy is something normal and is something that's necessary for many applications to find mainstream adoption. And on the other hand, building technologies that are a little bit more resilient than some in the past to misuse.
Yeah, so Fede, I completely understand about your lawyer coming to you and saying you probably should be working on privacy stuff. I've heard that a lot from a lot of lawyers, so totally resonate. Also, all the points currently being made, I think it's all sort of alluding to the fact that this is it's not as simple. It's not black and white about whether governments care. It's more about how they should care, right? Because at the end of the day, what ends up happening is that if you have a scenario, right, like scenario A is blockchain and crypto is completely wiped off the face of the planet, in which case everything that we're doing here, regardless of its privacy or DeFi or saving the world, is useless, right? Because it's all gone. That's scenario A. Scenario B is you have a middle ground where things kind of plateau and they stay like this, and we're all just kind of in our own little Web3 circle and we do our little Web3 things, but it never really expands. And then scenario C, which is, I think, what a lot of us in this room are hoping for, and believe in, is this massive expansion of decentralization, self-sovereignty, the ability to kind of balance that control of your own data versus the applications that you're interacting with. In scenario C, I think privacy is critical, it's necessary, and I think that governments should think that way as well, because when you're leaking this type of data as an individual, you're the individual of a particular country, you're a citizen of that country. And that's no longer just a problem of your own country monitoring you, but all other countries also monitoring you. And this kind of alludes to CBDCs as well, right? Like, why is it that no one cared about CBDCs, but then all of a sudden China says, I care about CBDCs, and then everyone's like, well, we care about CBDCs too, right? No one's trying to be like, oh, I want to be like China. I mean, yeah, China, no, okay, I'm Chinese. But I'm not saying people don't want to be like China. I'm just saying that there's no reason for people to just say, I want to imitate another country. The reason people want to also start researching CBDCs is because CBDCs are a great economic infiltration into other countries to attack other countries' economies and take control from the inside, right? And so you don't have any sort of controls or defenses against this. Next thing you know, all of your citizens are going to be using CBDCs from another country, and now all of a sudden you have no economic control anymore, right? And so it's almost like a zero-sum game. And I think just as much as people care about the preservation of the value of their own currency, or when I say people, I mean governments care about the value of the preservation of their own currency. Governments, I think, also care about the preservation of the safety of their citizens. And so at that same vein, they do care about other government monitoring, in which case they should care about on-chain privacy in scenario C.
There's a very good video. I don't remember the name of the channel, but there's a frog on it. It's about what you just said. It's the whenever there's a hack, there's a web page where you can see the hacks.
How about that?
Which one? Yeah, right. There's a very good video of Rect speaking actually about what you just said, like about how CBDCs are going to be used with like other countries and how Ethereum, Bitcoin, and other assets on blockchains will be more interesting because they don't depend on one nation state. So I completely agree with you. Moving into more technical things, do you guys have any programming language on your particular blockchain? Are you using Solidity? How was that decision to come in the case of Noir? How did you decide to create a new language? Always creating a new language implies getting a lot of attention on creating a lot of tooling. It's like a very big investment. So how was the decision of using a new language, keeping the old one? How do you see that?
We developed an open source language called Noir, and I think it really started with addressing developer pain points. So we're kind of in this phase where we're looking at developers and we're like, we will do everything in our power to make it possible for you to develop in ZK easily. That means you have an unlimited amount of our time and our resources and improvements to the Noir language. And our developer relations team does an excellent job of improving adoption there. Our goal really is to try to disconnect. If there's one takeaway I want you as an audience to take away from Aztec today, is that Noir is not Aztec specific. Is that our goal with Noir is to make it a universally versatile language for ZK development. And our hope and our go-to-market is if we build this open source public good and it's useful for everyone, then eventually someone will incorporate Aztec smart contract syntax and come over to us. But even if that doesn't happen, we're happy to have created this universally well-liked public good. And so that's really our mission with Noir and why we developed an entirely new language.
We also have our own language in Ola. It's called Olalang or Olang. And why we have that is also to make it more convenient for developers, but also that if we're looking at Ethereum, Ethereum is not compatible with privacy. We're using UTXOs under the hood, and as you may know, Solidity is not compatible with UTXOs. So that is one of the reasons. And with Olalang, we're also trying to make it as accessible and easy to use as possible. So one of the additions we're making is, first of all, it's Turing complete. So you can deploy any arbitrary logic on top of Olang. And we're also looking to abstract away all the complexities that is there with ZK. And this is slightly different to some of the other teams where you have circuit writing into the language, making it a DSL. So we're trying to abstract that away. It's kind of like, and I had this metaphor before in my speech, but if you walk into a room and you want to turn the lights on, you just flip the switch and it works. And that's the level of abstraction we're looking to have in Ola. So we have constraints on the VM for ZK purposes, and then you can deploy as any arbitrary code, and you don't just think and worry about the ZK writing and ZK circuits. It's just taken care of. And that's also why we have Ola.
Yeah, so for us, we took a bit of a different approach, also because I think Aztec and Ola are a bit lower down in the stack as being a L1/L2, whereas we operate directly on the chain. And so for that reason, for us, we took the approach to rather just grab an SDK that works with the existing language of said chain. And the thought process behind that was a bit more so in the direction of saying, for a developer to learn new language, oftentimes is, even if the language is easy to learn, it's still a big decision to take because there's 100 different languages or 1,000 languages even these days, and there's so many trade-offs if you decide to learn one more. You could have learned Go or some other cool new language instead of the elusive language if we had one. So that's why we decided to go with existing languages, because the idea then is you have to learn how to use the elusive SDK, okay? But then if you decide, oh, elusive doesn't work for me, or I want to continue working on something different that doesn't have anything to do with privacy, at least you didn't invest as much time learning a fully new stack for it, but rather the skill you learned learning the language, for example, Solidity that you're using with the elusive SDK, you can still apply that to a different project. So in that, we think it lowers the pain a little bit for new developers to onboard onto privacy in that sense.
Yeah, so for us, I guess it's a little bit of both. We have some sort of adaptability in terms of languages, and no, depends on which environment that you're building in. On the L1 on Manta Atlantic side, there is no new language. It's not a Turing complete chain. It is UTXO based, and so for the exact reasons that OLAP VM is doing it that way, right? And so Manta Atlantic is specifically focused on deploying various aspects of on-chain identity. Manta Pacific on the L2 side, we are also kind of taking that abstraction approach on the SDK side. What our whole premise is, or what the thesis is here, is that instead of having to focus on the complexity of building these types of circuits for the average Solidity developer, which everyone here kind of, we're all saying the same thing, right? We want to abstract it and make it a lot easier. That's exactly what we're doing as well. We're just kind of compiling these into smart contracts that can either be called directly through the interface or also through SDKs. And that I guess like the key difference here is that ours is specifically focused on Solidity developers rather than the language that's adapted to the VM.
Yeah, I will enter a little bit more the technical discussion. Which pooling system and why did you choose it, and how do you see that mixed with the hardware acceleration? Like, do you think it's going to be very important? Do you think it's close to be ready? I have my own opinions. That's why I wanted to know how you see it. Like, for example, Stack based, like Ola. You're Stack, right? Stack based, or
We are Stack.
yeah. So, for example, I understand from my point of view how hardware acceleration is not that important, but I wanted to see like how each of you see the proving side on the hardware acceleration side of things.
Oh, sure. So I guess proving system, we're a family of Prop 16, and we have proven this with our trusted setup, I guess. And I guess on the hardware acceleration side, so we haven't really been focused on gearing towards particular hardware, just because I think that with on-chain privacy, with ZK, it has to really be hardware agnostic. This is because, for the end user, the person that's actually touching the applications, you don't know what device they're using, right? It could be a modern laptop, it could be a modern computer, could be a cell phone, right? Whatever it may be. And so it's more about, focusing on the optimizations rather than having to depend on any particular hardware. So I guess we haven't really, focused that much on the hardware acceleration side.
Yeah, for Lucid, I can basically echo what Kenny just said. We're using GOT16 as well. And yeah, same idea. Like, I don't believe that hardware acceleration, specifically Lucid, what's used for most at the moment is DeFi. And in those cases, most of the time the user that's visiting it, it's just visiting it from his computer, which doesn't have any special chip. And my thesis is that probably not that near time in the future either. It will have a special chip that is very good at doing particular zero-knowledge operations. Yeah, we're just more focused on optimizing it on the software side rather than hardware side at the moment.
So at Ola, we're doing both. We've actually changed our CK backend many times. We started actually looking into cutting FFT and using MSM. Yeah, you shouldn't, right? And then, as new research comes along, and there's many articles being released all the time, and we kind of figured, well, okay, we see that this is better now, and that's how we ended up using Stark. So our CK backend is composed of Plonky 2 and Starkey, and then we've also looked into adding F-Plonk, which is a Snark Plonkish final step to succinctly have that to whatever layer we deploy upon. So many different steps here. And we are also open to following the research. I think things change, evolve, and adapt over time. And what we have today, which seems to be the best tech stack, might change in the future, in the coming month or months. So we're always actively on the lookout to study this. And we recently did a lot of studying on the sum check schemes and also of incrementally verifiable computation with the building schemes of Nova, Supernova, and Hypernova, and so on, which could also, in theory, be applied to our solution. And our engineering team is actively looking at this. And we have done a lot of research, extensive research on the hardware side of things as well. I think we spoke about end user devices here, and I think we all kind of share the same pain points here, that probably a phone, depending on the workload, would not be able to calculate many proofs. So most likely we'll be looking at more computationally heavy proofs being done. So a laptop on client side would probably be required. We are at the moment doing a lot of research on GPU, specifically acceleration with NTTs. I'll be touching upon that, I think, briefly in my workshop later on today. And I think in the future, we would probably be seeing maybe FPGAs or ASICs be developed for this purpose as well. The problem with ASICs is that they have a write-once logic, whereas FPGAs and DPUs are reflashable. And that means that if you develop some logic on your ASIC, that's catered to this very niche and specific use case, and then if anything changes on the software side of things, you're going to have to start from scratch. So I don't think it's feasible today with the rapid advancements we have in ZK Tech, but I think we might see ASICs in the future, kind of like how we saw ASICs come for the Bitcoin network.
Our crypto backend for Edinburgh is Bonk-based and includes a couple leaps forward from our cryptography team, including a move to Honk, which is our next generation proving system. I think Aztec is still a bit away from mainnet, so our team is still researching how to speed up proving. But I will say, as a shill for, again, Noir being an open source and completely backend agnostic language, what we want to do is, let us figure out what's optimized for Aztec. But as a developer, as a ZK dev, you should be marrying a language that allows you to be totally future-proof. And so Noir compiles to an intermediate representation and allows you to plug in any crypto proving backend, allows you to be totally future-proof. So right now we have our Brandenburg backend, we have Draw 16. I think yesterday Halo 2 just shipped. And so these are APIs and backends that you want a better UX, a better front-end UX to interact with some of these proving systems, but still want some of those capabilities. Noir is the place where you should land.
Cool. On the NTT, we have a repo called LambdaWorks. It's an open source thing. We have been doing quite some work on making the entities very fast, and you can run them on web GPU, CUDA, Metal. There's amazing work being done by the CUDA team in NVIDIA. They just released a library that's not very well known in the crypto space called QFFDDX, so that you can run changes on the FFT on each kernel. So there's a big advances coming on all the fronts. So I have one last question. I don't know how much time we have left, because I was checking my phone, and since the time changed, I don't know very well. The last question I have is how do you? I think privacy should be the default. Privacy should be for common people. But do you have any clue on how we can avoid or catch bad actors using our networks? Is there any way or any potential tool, or is there any way of having privacy but also being able to have some way of catching hackers when they have some protocol or when they want to get out of the network? What's your take on that? I don't know enough about it, so probably you guys thought way more than me on that.
Yeah, our founder and CEO, Zach Williamson, has been working with Vitalik on this notion of cleanliness providers, which is positive attestations by third parties, still decentralized third parties, about the cleanliness of kind of like your transaction history. And this is kind of this notion of a social consensus layer for good actors, right? I think what we don't want, in my opinion, is a backdoor, right? That you don't want a privacy backdoor where someone can open the door and be like, okay, this, and this person should go to jail. And so this might not be a perfect solution, but the idea of cleanliness providers is positive attestation of good behavior. And so if you can get everyone to default to positive attestation, say, hey, I'm going to provide a cleanliness proof that's been validated by this set of third-party testers that I haven't touched any bad funds, and everyone does that, then there's an implication that if you haven't done that, you've done something wrong. Not a perfect solution, but I think we're in the early stages of balancing these two things. How do you provide trustless privacy without opening a backdoor?
Yeah, it's a very good question, and I think it's a nut to crack here that we really haven't fully cracked. But what we're doing at OLA is that we're trying to design as much as possible compliance-friendly scheme So what we're doing is we want to maintain end user privacy. We want to maintain the computations and calculations to be private, meaning the transactions that the users are doing in the system. But we have a system where we allow for tracing of what we call commitments, which is basically just encrypted plain text data of that said transaction. So a quick example would be if Alice pays Bob, which is a different person, we could see that from publicly the first transaction that Alice is the sender, but we can't see the recipient. And then if Bob maybe goes ahead and pays Kenny over here, we can see that some transaction took place between Bob and Kenny, but we don't know who these two entities are. So maybe an example given, if you have some hackers then doing bad things, and you can identify that the initial funds were actually from malicious actors, then you can go and pinpoint through the system to where that funds is gone. And if you ever want to exit the OLA ecosystem, they would have to go back to that last public viewpoint, and we can see that. So we're doing these steps to counter and tackle these issues, but still at the core of the protocol, we want to maintain that fundamental need for user privacy.
Yeah, so we have a bit different approach to that as well, considering that we live, like in general, the way Elusive works is that we live on an existing L1 that's public by default, and we add our smart contracts, add privacy to that public layer. And in applications similar to ours, frequently the way you approach compliance is one of two ways, which in my opinion are both flawed. The first way is basically viewing keys or something equivalent like that, or checking that you're not on the OFAC list when you enter certain privacy smart contracts. This is flawed because viewing keys on one hand frequently has the problem that, if you're good at it, you can prove that, which is nice. But of course, if you're trying to keep a bad actor out, no bad actor will ever generate a viewing key, obviously. And wanting to isolate him will require everyone inside the pool to generate a viewing key, which doesn't scale beyond a certain size. And checking that the bad actor isn't that the person depositing isn't inside of some blacklist or some something like that at deposit or withdraw time has the flaw that the bad actor can just send it across 1,000 addresses before entering your system. So you and of course the knee-jerk alternative to that is to KYC everyone, but I don't think they need to explain why that's not a good solution. So we at Elusive came up with something we call Elusive Zeus, which is what we're kind of developing right now. Where the main idea is basically that frequently in past systems, you have the case that someone hacks a smart contract on chain, for example, and everyone can see, oh, this address is the one that hacked the smart contract on chain. And most participants in the privacy protocol or on chain in general would probably have consensus that that specific bad actor should be protected, or at least not in the same way that good actors are. And so using MPC, we derived a way which my co-founder actually gave a talk about how exactly the tech behind this works earlier today. We can capture this on-chain consensus and transform that into revealing certain transactions retroactively within a certain time frame. So we think this is quite powerful because this gives a good trade-off between the worst case scenario where you have one central point of failure that is basically a backdoor that controls everything, and the other case where it's fully decentralized and there's no way to recover from a bad actor. So, yeah.
Yeah, I think there's been a lot of great examples of this sort of balance. And the question itself, when Fede first asked it, was he was kind of struggling to find the right answer to it. And I think we all struggle to find the exact right answer to it because there is no right answer to it. And so, I think one of these challenges is that, just as we are all building on the infrastructure side to enable these types of features and functionalities on the application side, I think it's also a responsibility on the application side to decide, what side of the line they stand on, or how far they want to go, right? And so I think with these types of infrastructure level technologies, then we enable all sorts of different versions of the same type of use case with a spectrum of various different levels of compliance, regulatory adherence. That's something that I think will naturally kind of form. And I don't think it's up to us to necessarily have a say in what's right and what's wrong. I think it's just part of the markets, like it is, as long as there's some type of value to be derived, there's always going to be a way to derive it, and there's going to be a good way to do it, and there's going to be a bad way to do it. Yeah.
Do we have time for last question? Well, I will ask it. Today, Sama.
Sorry, is that a thumbs up or a thumbs down? Just looks like
I'm not
a blurry
seeing.
hand.
Yeah, okay. Thank you. Sorry, I missed you having the clock over there. So I had a last question related to something a little bit different, but it's related to privacy. I'm not a cryptographer. I'm coming from engineering. Only 1 or 2 years ago, I learned about fully homomorphic encryption because I was checking a company, French company called Sama. There was also one really interesting called, I think, Sunscreen from the US, if I'm not wrong. I have been following the development on today, I think, or yesterday, they launched an EVM that uses fully homomorphic encryption. How do you see the interaction between ZK and fully homomorphic encryption? It's something you're looking, it's something that you believe is too slow, that it's not important. In my case, I believe ZK is more important. Having FAG without ZK, I think it's complicated because you cannot verify what happened on FAG. But what's your take on it? Do you have any opinion? Maybe it's a too open question, but I would like to know how you see things.
Sure. So I'm kind of speaking on behalf of another project now that actually does combine ZK and fully homomorphic encryption, specifically for the purpose of designing on-chain poker. And so I don't know how many of you guys are familiar with the idea of mental poker, but it's this conundrum where, if you and I, one of us, were playing chess together, it's very easy to play chess in our minds because we know exactly where the pieces are. Everything's fully transparent, right? The only untransparent thing is our strategy, right? So I can say knight to d7, and we can both agree that knight is now on d7, unless it's an illegal move. But it's not the same with poker, right? Like we can't agree on which cards should be where in the deck without revealing the cards, right? And so we can't really mentally play a game of poker with each other. And that very much translates into how we build poker on the blockchain, or trying to solve for mental poker by building poker on the blockchain to peer-to-peer players. And so this group is specifically using the homomorphic encryption for the shuffling, and using ZK for the proof of that shuffle. So I mean, definitely, I think there's ways that you can kind of do like a 1 + 1 = 3, and I think this is definitely one of those scenarios, because fully fair, trustless poker is definitely a challenge to build. Yeah.
What's the name of the project?
Oh, it's called ZK Hold'em. Yeah, they're actually right next to us in the the main venue.
Yeah, so to be completely honest, with Elusive, we don't really use FAG for anything. So I don't think I'm too qualified to exactly comment on it right now. So
Me neither. So.
Yeah, I'd say the same thing, that I'm not educated enough on the matter to give a good opinion. But it's been interesting to follow. I think even Google was looking into this way back with their search engine, where you give it some prompt and it shouldn't know about what it's performing calculations on, and spit out the result back to you. And I think they had a massive engineering team working on this for quite a while, and then they realized, oh shit, our main source of revenue is from targeted ads. And they were like, they shut down the entire operation because they realized, well, we're killing our own business model here. But I actually think this was 13, 14 somewhere, where they had a big team working specifically on this.
Yeah, they have a good compiler.
Yeah.
Myself too, I believe.
But yeah, I guess that's the only input I can give to this discussion.
Yeah, I can only represent the opinion of our team, which is FAG kind of seems like a holy grail, being able to do compute over encrypted data. The way that Aztec works is you kind of have to download an encrypted note, open it up, do some compute on it, put it back in, submit a proof with the encrypted note to say, hey, look, the compute that I did locally is legitimate and follows the rules of the blockchain. And so that's kind of the subtle difference. With FAG, you kind of just send your encrypted data to a server, and then they can do it fully homomorphically. That feels like a holy grail. I think our team feels that it's quite far away, but we're looking into FAG techniques to potentially reduce, for instance, the amount of encrypted data you need to download to your own machine. Currently, the way we do it is trial decryption, which is we're just going to open all the nodes sequentially until we're going to sort through all the nodes until I have the one that belongs to me, and then I'm going to open it up and do my compute on it. Whereas with an FHE technique, there could be something called oblivious message retrieval, where you essentially ask the node for your encrypted note. They provide the encrypted note, but neither party kind of reveals any information leakage. We're still very, very early in research, but we're a ZK project, but really we're a privacy project first. So we're looking into any technology that can help us make privacy unimpeachable.
It's really interesting how ZK in particular on the economic incentives of the blockchain are pushing all these new cryptography related projects, because FHE, like for me 2 years ago, was like science fiction. But now for me it also seems like a little bit far away, but it's coming closer. ZK has done an amazing job and also the incentives for that. So thanks everybody. Please give a big applause to Nicolas, Philip, and Kenny.
We still have a few minutes to ask questions from the audience, so if anyone has, you can ask. Okay. Then the next presentation is by Manta Network and Kenny.
We're about 15 minutes behind.